Tim Wollery, he's the Vice President of Sales for Advanced Chemical Technologies in Oklahoma City, Oklahoma. He's going to be presenting on preservation of bridges using silane water repellents.
We're going to look at this a little bit differently. You heard about the corrosion inhibitors that are added to silanes, and we're going to talk a little bit more about what the DOTs are currently doing around the country, how to write a specification, some things like that. What we're going to talk about is the problems, which is typically water. We're going to go a little bit over what silanes are, a little bit in the chemistry of them, a little bit about the difference between them. We've already covered corrosion inhibitors with just a second. It was great. We'll talk about the testing and how long these have been tested. They're still today being tested. Application techniques, writing specifications, and then the cost. Water's a real enemy here. You put chlorides on your bridge decks, then it rains, and then the chlorides soak into the concrete, your rebar starts corroding, and we've been talking about that all day long about corrosion and rebar. So if we can keep the water out of the concrete, we protect that rebar. So a lot of these things you see every day, freeze-thaw damage, spalling, scaling, cracking, ASR. Is ASR a problem out here in the West? Kind of? Okay. ASR, I know one of the projects is in Arkansas as a few years ago, the runway at Fayetteville, they kept pushing the asphalt at the end of the runway. And so they kept trying to figure out what was going on. So the runway, when it was poured, was 3,000 feet. Later on, a few years later, it was 3,005 feet. Well, at the same time, Arkansas had poured 28 miles of interstate with that same pour. It was a real problem. So they put silane on that entire roadway to mitigate that problem. So if you don't have ASR problems, thank goodness for that. This is what I see when I go around the country a lot. The decks, we do a lot of work on the decks. It's the glamour. But then when you get to the underneath the substructure, this is what I see everywhere. Does this look familiar to anybody? Yeah. This could be easily prevented by using silane on the substructures. We spend all this time on bridge decks and neglect the substructures, and this is a problem. I mean, it's a problem in Oklahoma. It's a problem in New York and Maine. I see it everywhere I travel, is the substructures not being treated, not being taken care of, and now you got rebar sticking out of there. And now you got to fix it when it could have been easily prevented. And we'll talk about, I like to see maintenance crews do these kinds of things. Silanes is one of those things that maintenance crews can do quite easily. Why silanes? They work. They're super easy to apply. You were going to see in a minute that it's extremely cost effective. They last for years. I'm going to go through that Oklahoma State study that we talked about. It doesn't change the skid resistance, and they dry fast. Some silanes will dry in 15 to 30 minutes. So it just depends on how you write your specifications, what you allow in there, what the dry times of those are. From hydrophilic to hydrophobic. Concrete loves water, right? It'll drink it in there. If you've been out by my boots, you see a waterfall out there, and you just see that piece of concrete soaking in that water. And so they soak it in. So if there's chlorides on there, it's going in. It has nowhere to go. Silanes turn, as Atris talked about, it turns it from it forms that covalent bond with the silica in there. It makes them hydrophobic. This is loose sand. That demo is out there. You can take loose sand, coat it and saturate it with silane, let it dry out, and the water will not penetrate through there. This kind of shows you that depth of penetration that you get with silanes. When this block was dipped in silane, and you can just see that the water just stays out of there. It cannot penetrate through there. Talk a little bit about the difference, not to talk a whole lot about the chemistry of these, but typically there's about 6 silanes that are commonly sold into this industry. These all have great names of them, but typically there's like there's isobutyl's. This is that first word of there. And so when it's isobutyl's, N-octyls, and isooctyls. And then you have in there trimethoxy and triethoxy after that. All these silanes perform basically the same. They all penetrate the concrete. They all make it hydrophobic. The biggest difference in all these silanes is the dry time. So when someone comes up and says, my silane is better than your silane, that's just not the case. It's kind of like the spread rate, which we're going to talk about in a few minutes. So the isobutyls are the fastest drying silanes out there. They dry the fastest. Then it's the N-octyls are the next fastest, and then the isooctyls. So under the isobutyls, like the trimethoxy is the the fastest silane out there. The isobutyl triethoxy is the next fastest. To me, speed, I spent a whole lot of my life watching paint dry. Getting on a bridge and getting off that bridge is ultimately important because everybody likes to see their bridge closed for hours, correct? Yeah, no. So the whole deal is to get on there. So if you develop a silane program, I like to see faster dry silanes put in that spec just because you need to get on and off that bridge in a timely manner. Solvent versus water. That was talked about a little bit a minute ago. Typically the solvents are faster dry. They're recoatable. If you have to retreat, which we like to see retreat, it's always easier to do that. We can formulate those so that they are VOC compliant. Doesn't matter where you are in the country, a silane can be formulated to meet your VOC needs. And they're deeper penetration. When you're dealing with water-based, you can get lower VOCs, but now we're waiting for water to evaporate. So, I mean, the water's got to evaporate before that silane can really start penetrating in there and they just don't get as deep as penetration. Silanes have been tested by everybody. Oklahoma started a silane study in 1976. They did the first bridge in the United States in 1977, which was a Bird Creek Bridge. All these DOTs are constantly testing it. Same with universities. Purdue University is doing this study. Nevada University did a study. I think we looked, and it's on the website now on the Nevada University study. I sent silanes to Kansas City last year. It's like because you apply it and then you can't see it, is it really there? Does it really work? It's a constant study. This is a 1985 report from Chaney, Elsner. It looks like it was typed on an IBM Selectric typewriter. A 48-week corrosion study and a 40% silane, 125 square feet per gallon past the chloride intrusion test. They've been around a long time. They're proven, it's a proven technology. These are some of the tests that if you're writing a spec or if you look at someone's data sheet, you're going to see all these different tests, the C672, 642. It's just constant redundant testing of all these things. This is a Rythm Tube test. And this is what people do. Pouring out the ciders, it's soaking in that concrete. Can you tell? I think it's running, but for some reason this slide flips. But so this is a way to test moisture absorption into concrete. Typically not done on bridge decks, but it's done all the time on vertical buildings, and it's done all the time on parking garages. So you pucky this Rythm tube down, you fill it with water, and it determines the moisture, how fast the water gets soaked in. So you run this test on your structure prior to applying a silane. You let it dry for cure for a few weeks, then you go back and rerun that test, and you can see the difference, and you can monitor how much moisture that's actually taken in. But yeah, so the treated is the one on the left. The one that's not drinking in the water is the one that's been treated. Does that make sense? This is the Oklahoma State study that was just performed a few years ago. Oklahoma State, Walt Peters with Oklahoma DOT asked how long do silanes last. So Oklahoma State University tested 60 bridges. They pulled cores from 60 bridges to do this study. And out of those bridges that were 6 to 12 years, 100% of them still showed silane in them. Bridges that were 15 years, 66% of them still showed the presence of silane, and bridges 17 to 20 years, 21%. So when someone asks how long do silanes last, according to Oklahoma State University, they last 6 to 12 years. So you can typically think that they're going to be in there for a good 10 years after you apply it. Talk a little bit about surface preparation and application techniques, because this is, to me, is what's important for the people in this room about, okay, we're going to start a silane program. What does that look like? A lot of states sweep their bridges. A lot of them just blow them off with an air knife. You can power wash them. If you have a washing and sealing type program, which a lot of states do now, they wash the bridges, but now you've got to wait a day or 2 days before you go back to treat them. The concrete needs to be dry to get maximum penetration. Oklahoma, we shot blast. They build a new bridge, they let it dry, they let it sit out there for a year and crack, and then they come back and they shot blast it, and then they treat it. Everybody familiar with a shot blaster? This is a drone video. We did a project. We used a drone out here to take pictures of this. It was pretty impressive. They're pretty amazing things. So you can just see how clean that shot blaster gets it. It's not a super heavy, it's just a real light. It's more than a brush blast, but you definitely can remove everything out of that concrete. But Oklahoma is the only people that I know that does this. And Oklahoma is the only people that I know that core their bridges to pay their contractors. Oklahoma pays their contractors by two ways. They do visually inspected, which which we put a dye in there, and then they can see what that looks like. Then the inspectors can tell that it's been sprayed, the fugitive dye, or they pull a core, and the contractor gets paid on depth of penetration and running a moisture absorption test. It's a tough test. As far as applying the silanes, I have a lot of states where contractors just hand spray it, walk behind spray bars, or truck or trailer mounted. The key to this is getting it close to the ground. You can see with this, they're kind of pushing that puddle. This is in Arkansas. This has the blue dye in there. They're applying this at 125 square feet per gallon. It's kind of pushing that puddle. I like spray bars because it doesn't atom. You do not want to atomize these. If you get too high a pressure of spray and you're atomizing these silane, it's good for the silane manufacturer, not good for you. You're trying to get as much transfer efficiency as you can. So when that spray bar is that close to the ground, there's not much waste. This is a truck mounted unit. This is from Illinois. This is pretty close to the ground. Now I'll show you. Indiana's not here, so we can talk about them. This is trucks that Indiana built. Do you see the problem here? We were eating that stuff. More of it was probably in our faces than it was on the bridge deck. So if you're going to build a truck mounted unit, you need to get it low to the ground. Part of the problem with truck mounted units is if you're applying this at say 200 square feet per gallon, driving slow enough becomes a real issue with how do you drive it slow. If you're doing huge bridges, it's a great way to do it. And you can see traffic's going right by while it's going on. This is maintenance crew doing this in Indiana. Indiana started a maintenance program where their maintenance crews are doing all this work. Yeah, they went back and moved the truck over. This was just a trial. Ed asked did you ever hear the question, did they do the shoulder? And yes, they did. Hand spraying, this is probably, there's a lot of contractors think that this is a fast way to do this. In Tim Wollery's opinion, this is the most transfer inefficient way to do it. I mean, it's just a lot of labor spraying it this way, but this is in Illinois and they're spraying the barrier walls there. At the same time, they spray the top and the barrier walls. No substructures are being done in any of these states, but they're getting the decks. Let's talk about writing a specification. Typically silanes, when we were talking about all those ASTM tests, those are typically run, let's say on a 40% silane. Typically we like to see that written at 100 or 125 square feet per gallon. That gives you 11 grams of silane per square foot. That's about where the silanes need to be effective to keep the chlorides out. So when you're writing a specification, if you're going to put a 20% silane in there, it needs to be at 60 square feet per gallon to get that 11 grams of silane per square foot. If you're going to write a 40% silane, it needs to be at 125 square feet per gallon, and 100% silanes need to be at 300 square feet per gallon. That's where you need to be. A lot of times a specification will get written, manufacturer's recommended application rate. Guess what happens? My silane will go 600 square feet per gallon. And it will. But you don't get the protection that you need. But that's what happens when we write specifications that say at manufacturer's recommended application rate. You don't get what you pay for. They're going to stretch it out. It happens every day all over this country. If you ask me to come help you write a spec, this is how it'll be written. We're going to say, if you're going to use 100% silanes, we're going to put them down at 200 or 300 square feet per gallon. And that way you get what you pay for. And then when your inspectors are out there, they're going to say, this bridge deck is so big, this many gallons need to be put down. I want to see it out of that drum or out of that tow tank. I want to see that many gallons put on my bridge deck because that's what I paid for. So be consistent in writing specs. You heard a minute ago about weather matters. 24 to 48 hours after a rain event. If it's been raining for days and days and days, it may be longer than 48 hours. If it's in Oklahoma and it's been 105 degrees and it rains in the morning, tomorrow's fine. That bridge deck is dry. Rain after application of silane, 3 or 4 hours is no problem. It just helps it cross-link. Let's talk about the cost. If you put down a 20% silane at that 60 square feet a gallon, because that's what we want to get, and that gives you your 11 grams of silane. Let's say that costs $15 a gallon. You're talking 25 cents a square foot. Material cost, not application cost, material cost. So repeat that every 6, 10 years. I have some states that retreat every 3 to 5 years. Some go for longer than that. 40% silanes, 125 square feet per gallon, $20 a gallon. You're at 16 cents a foot. Here's the moneymaker for you guys. 100% silanes at 300 square feet gives us at 11 grams. Now you're down to 12 cents a foot cost. 12 cents a foot to prevent corrosion. Pretty inexpensive. Now the question should be, why is it getting cheaper as that silane goes up? Every time that we have to touch that in manufacturing, that cost goes up. So the 100% silanes are basically the raw material for making the 40s and the 20s. So we have to take it out of those tote tanks or out of the container. We have to blend expensive solvents in there. Then we have to re-QC it. Then we have to repackage it. So that's just that many more people that have to touch that. And then with that application rate, I mean, you're basically paying to ship solvent across the country. So that's why the best bang for your buck is to go to 100% silanes. Let's look at a kind of a typical bridge. This is kind of so if you've got a 150 by 38 foot bridge, costs you $140 a square foot. When I wrote this, that was probably a pretty good number. It's probably higher than that today. That bridge costs you $800,000 to build. So 5,700 square feet treated with a 40% silane, 45 gallons. So that 45 gallons at $20, $912 to protect an $800,000 investment. If you had an $800,000 car, would you change the oil in it? Even if it cost you $900? The answer is yeah. You probably would, because you want to protect that investment. Silanes are one of those things that truly protects your investment when you're building these new bridges. It's too easy to apply. It's too easy to use to not do it. They're tested. They've been studied. There's still studies going on this day to prove it. It's never too late to start a silane program. You just saw about what the corrosion inhibitors do for reducing rebar corrosion. So it's never too late. If you can keep the water out, those chlorides aren't going anywhere. They're super cost effective. They're real easy for local crews to do. I mean, silanes is one of those things that maintenance crews can pick up and do quite readily, and they last a long time. So that was more that's more corrosion testing. We need to see more of that. There's more tests that shows what those corrosion, that G109 test looks like. Questions?
You had mentioned that faster is better for getting off the bridge stack. Does that also correlate to less penetration, though?
No, it does not. The question was, does that correlate to less penetration? The answer is no. They're just going to penetrate in there. Sometimes the faster dry silanes cost more as far as that goes, and that's typically the deal. I mean, the slower dry silanes, those inoctals and isooctals, a lot of times are less expensive.
Like Indiana, they sprayed right over the top of the striping?
Right over the top of the striping. Right. Here's what happens to the striping. Typically, it can soften that stripe for a few minutes or a few hours, depending on the dry time of that silane, but that striping paint will reharden.
Faster is partly because it's absorbing faster, so it doesn't necessarily correlate to less penetration. Often it correlates to more penetration.
It's a smaller molecule,
Right.
basically, is what happens, and that's why that isobutyl is a smaller molecule than the isooctyl is. So you really get, so typically the penetration levels on all of them are not, I mean, it's not like one's going to go an inch and one's going to go a half inch. I mean, we're not talking that kind of dramatic difference.
The only other thing I was going to say, Tim, is Oklahoma really has it right with their spec. You were talking about specs and you were talking about square foot coverage. That 2 millimeters is really kind of the gold standard, because you pick where you're pulling cores from. We don't, or the contractor doesn't. So it's completely random, and then you have that depth of penetration that you were just asking about, Travis. So I think that's even better than giving a square foot coverage rate.
Right. Yeah, I mean, Oklahoma, they don't mind pulling cores out of their bridges. Most states don't want to be drilling holes in their bridges and pulling cores out of them to run that test, but that's what they do. And if it doesn't get the 2 millimeters of penetration, that contractor has a choice: no pay or go back and retreat. So they truly get what they pay for.
It sounds like you're recommending silane treatment on new construction.
I do. Yeah,
So
I mean,
you
28
have to wait
days
a
after
certain amount of time for the concrete to cure. Is there a sweet spot? Because based on what you're saying, the sooner you treat it, the less chlorides are going to penetrate into the.
You're
into
trying to get the
concrete.
most of the moisture out of that concrete. So yeah, so typically silane manufacturers recommend 28 days to get that concrete cured before they start their treatment. Yeah, so wait 28 days to water out of there. Now you know more about silane than anybody.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.